Hey guys, welcome to my channel, and today's topic is going to be on cell membrane and transport. This topic is divided into five types, and today I'm going to focus on cell types and plasma membrane. Let's get started. Cells can be divided into two types, that is eukaryotic cells and prokaryotic cells. So eukaryotic cells are usually, animal cells and plant cells, while prokaryotes are basically bacteria. Eukaryotic cell has different components in it, starting with the plasma membrane, peroxisomes, mitochondria, Golgi, lysosomes, RAR, nucleus, nucleolus, smooth endoplasmic reticulum, cytosol, likewise. Prokaryotic cells have cell wall, cell membrane, ribosomes. These are the usual things. This video, I'm going to be focusing on different components of each parts of the cell. Let's get to the membrane. This is the basic structure of the plasma membrane. You can see that it has the give me a minute. Just the laser. Okay, yeah. So you can see that there's a hydrophilic head and a hydrophobic tail. Hydrophobic means it doesn't like water. So basically, phobia means you don't like water. That's why the tails are all faced inwards and the heads are faced outwards. Together, this forms the bilayer, lipid bilayer. It also has components like carbohydrates, integral proteins, peripheral proteins, likewise. Let's look more into the functions of this. The main functions of the plasma membrane is it maintains the physical shape of the cell, and basically it just keeps things packed inside. And this also helps to control what goes inside the cell and what goes outside the cell. So this is supported by these integral proteins, and we will be going into more detail of this in the in the later topics. It also provides protection for these organelles inside the cell, like the Golgi, the nucleus, and all that. Again, it helps maintain the shape and size. Let's look into what carbohydrates do. Carbohydrates on the lipid bilayer, which is attached to integral proteins. This helps access receptors. So you know that usually when white blood cells and all that they scan your body cells, right? So they scan this through, checking these antigens, antibodies. It checks that. That is formed by the help of carbohydrates, and that's the main purpose of it being on the cell. Next comes the peripheral protein. This is attached to the surface of the lipid layer, and it's bound in a loose kind of way, which means that it's bound to the head groups. And that basically what I mean to say is it's on the surface of the lipid bilayer. And this usually can act as enzymes or receptors. Integral proteins are within the bilayers. This is spread throughout the membrane. And the main function of these are that it can function as enzymes or even transport carriers. These transport carriers are the ones that are going to be helping substances in and out of the cell, so which we'll be going into further detail in the later topics. There's a concept called the fluid mosaic models. This is basically a bit more complex kind of diagram. So in this you can see overall how it is. Glycoprotein is another name for integral proteins. And in here you can clearly see that it has all the heads and the tails, and you see this hydrophobic region. It gives you a clear idea of the entire cell structure and how the plasma membrane is supposed to be. So looking at the key components, that this was founded by Singer and Nicholson in 1972. And this is basically the foundation of the entire membrane. And so the reason for the name fluid is because it has a mixture of fatty acids, and these fatty acids are liquid at at cell temperature. So which means that it gives that entire fluidity kind of how would you say that fluidity look, I guess. Yeah. And there are no covalent bonds, which means that there is no bonds in between all this. It's all just like, it's just there together, that kind of thing. And the reason of the reason they say it's mosaic is because of all the proteins that are spread around the cell create some kind of a pattern. That's why they call it mosaic. And yeah, peripheral proteins again, they float on the surface of the cell membrane. Yeah, that's also one thing. And again, like we summarized before, integral proteins are submerged within the cell, and the reason for it being fluid is because all these proteins can freely move around the cell within the membrane plane. So since they are not fixed with covalent bonds, they can just freely move to all around all sides. That's basically the main concept behind this. This is just a small part of the video, and I'll be making more videos on. So the next topic is going to be on cytoplasm. And thank you for watching, guys. And if you guys want me to cover up any other new topics, please feel free to leave a comment below, and I can make the next video then. And thanks for watching, guys. Hope you enjoyed it and hope you learned something.